we have a complex number represented as a vector in an Argand diagram where the horizontal axis is the real component and the vertical axis is the imaginary component, so this might be our z, we can represent that in polar coordinates by finding this displacement or this magnitude, and this angle we refer to as the argument. So polar coordinates would look something like this, r at an angle of theta. And that would be equivalent to x plus jy, where x and y are the real and the imaginary components of our complex number. Now, it's fairly easy to find r. That's simply the square root of the real squared plus the imaginary component squared. But finding the value for the argument, or this angle theta, will depend on the quadrant we're in. So because we always measure the argument theta anti-clockwise from the positive real axis, so this would be our angle theta. So if our vector, if our complex number happened to be in this quadrant, then the clockwise angle, or the anti-clockwise angle, would look like that. The shorter way of doing it would simply be to go clockwise by minus theta. So the angle here, the acute angle, is still theta, but representing it would require as negative theta. So let me write the four examples, or the four possibilities that we have. We can either have our vector in, or our complex number in quadrant 1, quadrant 2, quadrant 3, or quadrant 4. So let's say that this angle here, alpha, is the same for all of these. So alpha, let's just say, is the tan inverse of y over x. I'm taking the absolute value to make sure whether or not x or y is positive or negative, we always get a positive number. And let's say, in this case, it was pi over 6, or 30 degrees. So in this quadrant, we can simply say the angle is pi over 6. If it was in this quadrant, rather than going all the way anti-clockwise, we would go clockwise by negative pi over 6. So I'd say theta equals negative pi over 6. If it was in this second quadrant, you would want to find this angle here, which is essentially 180 degrees, or pi radians, minus alpha, or minus pi over 6. So if I clear that, we can say here theta would be pi minus pi over 6. And here, in your third quadrant, it would be pi plus pi over 6. But that makes it bigger than pi, and we generally want our angle to be between minus pi and pi, so we don't generally like that. So the shorter way of getting to there is to go clockwise by pi minus alpha. So because it's clockwise, it's got to be negative, so we rewrite it as negative pi minus alpha, in this case pi over 6. So that will give me pi over 6 minus pi. So that's an example. In general, we can replace each of these with theta. So if I now clear everything, I can rewrite all of this as 4 possible values for theta. All right. So in this quadrant, theta would be simply inverse tan of y over x. In this fourth quadrant, it would be negative arctan of y over x. In this quadrant, it would be pi minus inverse tan of y over x. And in this quadrant here, the third quadrant, it would be inverse tan of y over x minus pi. Okay. So these are our 4 possible examples. So always a tan inverse will always give you the acute angle there. Okay, so you can always sketch this when you're answering a question, or you can just remember it. So you've got the angle, negative the angle, pi minus the acute angle, or the acute angle minus pi. So that's how you would find the argument theta in each of the 4 quadrants when converting to polar.